Number 89. Well, let me get back there. There we go. Use the data for males shown in the bar graph. Males. I guess it'd be the blue. Okay. At the bottom of the previous column, solve this exercise. Let X represent number of birth years after 1960 and Y represent male expectancy. Create a scatter plot that divides the data as a set of 6 points in a rectangular coordinate system. Okay. X is what? X is number of years after. Okay. So this is years after 1960. And Y is male life expectancy. LE for life expectancy. Now our first bar here is 1960. Well, the number of years after 1960 minus 1960 is 0. And life expectancy looks like is 66.6. So that's our first point. Now the next year is 1970. 1970 minus 1960 is 10. And it looks like it's 67.1. 1980 minus 1960 is 20. So that'd be 20 comma 70. 1990 minus 1960 is 30 years. So that'd be 30. 71.8. Okay, sorry. I don't know what I did. Okay. $1990 minus 1960. Am I still recording or? I had two versions of Snagit running, and I don't know what I did. But okay. Now, just to reiterate where that 30 is coming from, you just take the year minus 1960. So this is 1990 minus 1960. And that gives us 30. And the blue bar goes 71.8. 2000 minus 1960 is 40. And it goes up to 74.3. And I'm assuming this is 50, but let's see. 2010 minus 1960 is 50. And 75.7. Now those are our points, and I'm not going to do part A. Part A says create a scatter plot. That's just plotting points. Draw a line through the 2 points that show male life expectancies for 1980. 1980 was our third point. So this one here. And 2000. 2000 was this point. Use the coordinates these points to write a linear function that models life expectancy. And this is what your question was. Well, we got 2 points. 2070 and 4074.3. Step 1 is to find m. And m is going to equal to y2 minus y1 over x2 minus x1. Y2, if I label these, this would be x1, y1. This would be x2, y2. We would have 74.3 minus 70 over 40 minus 20. And not very good decimals, but let's see. If that's 4.3 over 20, what if that comes out nice? Okay, calculator. .3 divided by 20. If it's got a lot of decimals, then oh, that's not bad. 0.215. Step 2. Plug in one of the points in for x and y. Doesn't matter which one, whichever one looks easier. This one has less decimals. So plug 20 in for x and 70 in for y. M we just said was 0.215 times x, which is 20, plus b. And then I want to solve for b. So 0.215 times 20 gives us 4.3 plus b. Take the 4.3 over to the right side. 70 minus 4.3, 65.7. Now step 3 is a writer answer. Now I could write this as y equals mx plus b. But they mentioned something about to write a linear function of models life expectancy, e of x. So instead of y, I'm going to put e of x there. Now m, we said was 0.215 x, and b was 65.7. And this would be our equation. Now when they're asking you in part C, use it to project the life expectancy of American born in 2020. If I take my 2020 minus 1960, because remember x is the number of years since 1960, that would be 60. You'd then take that and you'd plug it into here. So we'd have 0.215 times 60 plus 65.7. And then that would give you whatever. Now realize you'll come up with a different equation here depending upon which points you pick. So if I pick the second point and the last point, I would get a different function. That's okay. Because you're trying to find maybe a good line that goes through those points as best as you can. Now 90 is kind of the same way, except for you use the female. So you go with the light blue, aqua, whatever that is. Never good with colors.